In 1991, a pilot plant test of 25 megawatt capacity started at the Nakoso Power Station in Iwaki City, Fukushima Prefecture. This pilot plant recorded stable and continuous operation for 789 hours, and the test was completed in 1996. Following the two oil crises in the 1970s, efforts were made in Japan to diversify energy sources so as to reduce the nation's excessive dependence on petroleum. As Japan relies on imports for most of its energy sources, it is very important to secure stable energy sources for electricity generation. Among these energy sources, coal is particularly important due to its abundant reserves, price stability, and the well-distributed countries of origin. The purpose of the Igcc project is to realize a new coal-fired power generation system that can promise the highest plant efficiency and superior environmental performance. Based on the success of the pilot plant experiment, a project was initiated to create commercial plants with the world's highest power generating efficiency. Aiming at the construction and operation of a demonstration plant of similar scale to commercial plants, the Clean Coal Power R&D Company Limited was established in June 2001 by Japan's 9 regional power companies and the Electric Power Development Company. The ultimate goal of the Clean Coal Power R&D Company is to design, construct, and operate an Igcc demonstration plant and to solve all underlying problems. Aimed at is establishment of the technology to realize efficient, reliable, and economically competitive commercial Igcc. In conventional coal-fired power plants, coal is burned in a boiler, and the generated steam is fed to a steam turbine to generate electricity. In contrast, in an Igcc plant, coal is gasified in a gasifier to produce raw syngas. This syngas is then led to a gas turbine. In addition, waste heat from the gas turbine is used to generate steam, which operates the steam turbine. Power generation in 2 stages like this is generally called combined cycle power generation. Thus, by combined cycle power generation, an Igcc plant can achieve high generating efficiencies of 48 to 50%, as compared to 42% of coal-fired power plants. In addition, the improvement of efficiency reduces CO2 emissions from coal combustion by 20%, helping to reduce global warming. An Igcc plant comprises a coal gasification facility to convert coal into the synthetic gas, a gas cleanup facility to remove air-polluting components, and a combined cycle power generation system incorporating a gas turbine and a steam turbine. An Igcc plant uses finely pulverized coal as fuel. Coal is processed by a pulverizer before being fed into the coal feed hopper. After entering the hopper, pulverized coal is pressurized by inert nitrogen and fed into the pressurized gasifier. The coal is then mixed with air, having a slightly increased oxygen concentration when it is fed into the lower section of the gasifier. This additional oxygen ensures more stable combustion. In the lower section of the gasifier, pulverized coal fed by the burners combusts and becomes a high-temperature gas at about 1,800 degrees centigrade, providing the heat energy necessary for gasification to the reductor. In this overhead view of the combustor in operation, pulverized coal and unburned char fed by the 8 burners are burned, creating a spiral flow that rises toward the reductor. At the top of the gasifier, the rising heat causes a gasification reaction and produces high-temperature syngas. The SGC heat exchanger, which is connected to the gasifier, cools the high-temperature syngas from the gasifier. The heat absorbed in this heat exchanger generates steam, which is sent to the steam turbine. The syngas cooled in the SGC heat exchanger is supplied to the gas cleanup facility. In this facility, air pollutants in the gas, such as sulfur compounds, are effectively removed in multiple stages. After impurities are removed, the clean gas is combusted in the gas turbine, which rotates the connected electric generator. The exhaust gas from the gas turbine is still at a high temperature. This gas is sent to the heat recovery steam generator, or HRSG, where the recovered heat is utilized for steam generation. The steam from the HRSG and the steam produced in the SGC heat exchanger are sent together to the steam turbine for power generation. Thus, in an IGCC plant, the produced syngas drives the gas turbine and the steam rotates the steam turbine. This two-stage power generation achieves higher efficiency. The IGCC demonstration plant is being constructed on the premises of the Nakoso Power Station of the Joban Joint Power Company in Iwaki City, Fukushima Prefecture. This site was selected considering the existing infrastructure and available utilities, including a coal storage yard and power transmission lines. As to the schedule of the project, 3 years are allocated for the design and for environmental assessment. After 3 years of plant construction, verification tests are being conducted for about another 4 years, starting in fiscal year 2007. The IGCC demonstration plant project was initiated with the key phrases of energy security, efficient use of energy, and environmental compatibility. To establish IGCC technology by maximizing cutting-edge technologies to achieve the world's top-level power generation efficiency and reliability, and to achieve early commercialization of domestic IGCC plants offering international competitiveness in terms of cost performance. The IGCC demonstration project for the new generation of coal power in the 21st century.